is just about how the angles are related within a trapezoid. What do you know about the angles? And this is a special Cruz. This is a special kind of trapezoid. What's special about it? Cruz, I don't have the control.
What?
What did you say?
FJ and GH are congruent to each other.
Um.
That's not special.
Yes, that is why it's special. So it's called. Do you remember the name for it?
Ma'am?
It's an isosceles trapezoid. When two legs are the same, it's called isosceles, just like an isosceles triangle.
Oh, okay, I see.
So 4 and 5 are both isosceles.
Okay.
So if they're isosceles, you know something about their angles that touch the bases, and the bases are the ones that are parallel.
Mm-hmm.
So do you remember what you know about those? What's your base angle?
About the isosceles or the
About the base angles, like
base angles are congruent to each other.
Yeah, F and G go together, and I'll use another color, and then J and H go together.
Yeah.
So if J is 110, H is 110, how are you going to figure out F and G?
Well, you could do 110 plus 110 plus X plus Y equals 360 degrees.
Almost exactly right, but instead of two different variables, since F and G are the same thing, keep them the same variable, because if you have two variables in there, that might get confusing.
Oh, okay, I got you. So 220 plus X, 360.
Did you get it?
140.
That is the total. Let's see, 220 plus, and you got two X's, right?
Yes, ma'am.
Equals 360. So that'd be 2X equals 140. Then what?
Divided by 2 equals 70.
Yes. So each of these, G and F, are 70.
Awesome.
Need tissue, buddy?
What? Oh, chair.
No, don't wipe it on the chair. All right, see if you can do 5, because it's just like it, just different numbers.
Okay. Well, F is going to be 68 degrees as well. 68 plus 68 degrees plus X equals 360 degrees. 68 plus 68. 136. 36 plus X equals 360.
What did?
Thank you, Cruz. Here, if you need it again, okay?
What?
It's right there if you need it again, okay?
What?
You heard me. Get it?
Almost there.
Okay.
That's 112.
You got it. So that's each of those. In a theorem that we looked at yesterday, it tells you about the mid-segment, how you find the mid-segment. Do you remember?
I didn't get all my theorem postulates and theorems down, but I can look and see if I got it down. The last one I got was on the trapezoids.
These are trapezoids, 6 and 7.
So
But
I got all three trapezoid things.
Okay.
So I got
This one's about the mid-segment. What would you do for a mid-segment?
The trapezoid is isosceles if and only if it's diagonal circumference.
Is that the last one you had?
Yes, ma'am.
Okay, this one comes after it. It's another trapezoid one. Let's see. Let's see if I can look at the book page and I can tell you. What page? Let's see. Page 538.
Okay.
It has mid-segment theorem. The mid-segment is parallel to each base, and its length is 1/2 the sum of the length of the bases.
Okay.
So if you're looking at where's it? There you go. 6 and 7. Let's talk about the mid-segment.
All right, I'm going to go to the book page and look at this theorem.
Okay.
Copy it down.
Okay. Well, I'm going to mute it. When you need me, let me know.
Okay, thank you.
How's it going, Braden?
Good. I'm just solving these problems out.
So you're understanding them okay so far?
Yeah.
All right, wonderful. Just checking in.
Yes, ma'am. Thank you.
Mm-hmm.
For number uh for number 8 and 9, I did have one question.
Okay,
Um,
let me scroll it up.
so I was thinking M is congruent to K. Is that correct?
Is correct. For a kite, there's one set of opposite angles that are congruent, and it's the ones that are between the sides that are not congruent. So M and K in this kite, and then M and K in this kite would be congruent.
Okay. So I need to do 60 plus 50
Mm-hmm.
plus X equals 360.
Almost. Well, depends on how you're thinking X. If you are thinking of X as M and K together,
Well, and then divided by 2 like we did earlier.
yes, that's fine.
Okay.
Or you can think of each of them as X and then do plus 2X. Either way is okay.
Okay. So I got 50 degrees.
Got more than that.
Is it? Oh, wait. Oh, I did that wrong. Hold on. $125. My bad.
Yes.
I did math in my head, and that never works out for me.
Sometimes it can, but it's easy to make mistakes if you don't follow through all the steps.
Yeah.
The 10 and 11, we haven't talked about those properties of kites yet. So that was one where I was like, maybe if y'all see the property in the book, you could get it. Let me see what page. We will talk about it Wednesday, but for a kite, the diagonals are perpendicular also. So that'll help you in the next ones because it makes right angles in the middle, like here and here. So that's why it's talking about Pythagorean theorem, because you can only use Pythagorean theorem if you have right triangles.
Mm-hmm.
So if you know that those diagonals make right triangles inside there, then you can find things that are missing to find the side lengths of the kite.
So you want us to do these, or you don't want us to do these?
I wanted y'all to try them. I don't know how I worded it to your class, but I tried to word it to the classes for the ones on kites to read what the book says about kites and see if you can kind of transfer that knowledge, see if you can use the facts to solve them. It won't count against you, but I didn't want people just be like, forget it. But basically, in a kite, you have two sets of congruent triangles. So like number 10, those top two triangles will be the same, and the bottom two triangles will be the same. So you're kind of going to do Pythagorean theorem twice. The top one, here's one of the triangles, and it's got 5 and 5. So you can do Pythagorean to figure out the hypotenuse there. And then the bottom triangle, the two that are the same, are 5 and 12. So you can do Pythagorean to get this.
Okay. Then you'll find...
Well, that's all it wants. It wants you to find the side lengths of the kite. So if you find those things I made darker, that'll be the same as this side and this side.
Okay, so x squared equals 5 squared plus 5 squared.
Mm-hmm.
And then solve that out. And then x squared equals 12 squared plus 5 squared.
Mm-hmm.
Okay.
And the bottom one actually is a triple, if you can think of what triple it is.
18.
Not so big. That's 7. No, 5, 7. I always forget that one. 5 something 18.
Yeah.
This one's 5, 12, 13. 13. But if you forget, if you do Pythagorean, it's 144. Oh, plus 25. So 169. And the square root of 169 is 13. If you forget triples, Pythagorean will always work. Just triple saves you a tiny bit of time if you remember them. And then notice it says simplest radical form. So when you get to the end, don't do a decimal. Just simplify a radical.
Okay. I'll try these two out and then I'll get back to you on this.
Have any?
Oh, I'm sorry. I didn't hear what you said, Miss Wen.
That's okay. I was just saying, do you have any questions?
Oh, yes. For number 16.
16. All right. Let me scroll. Let's see. Okay. So, is it a kite? How do you know if something is a kite?
If two of the sides are congruent. I mean, like two pairs of the sides are congruent.
Two consecutive sides.
Yeah, two consecutive sides.
Ones that meet together. So how would you know that in this problem?
By finding the distance of each segment.
Yeah, there you go. So one of them's really easy. You don't have to do the distance formula. The one that goes from the pool to the restaurant, you can just count it to save a little bit of time. 1, 2, 3, 4, 5, 6. So that one's 6 because you can just count on the graph. So you're hoping from the pool to the miniature golf is also 6 because that would be the side that touches it that looks like it's the same. So the big square root. Let's see, what is that? 1, 2, 1, 2, 3, 6. I think if I counted right, those are the right coordinates.
I think so.
So you plug them in. You say, let's say 7 minus 1, 5 minus 7. It's a 1. Kind of looks like a 9, sorry. 6 squared. Negative 2 squared. So root 40. Is that what you got? I'll make a mistake somewhere. I may have made a mistake.
I'm just gonna check.
Please do. Negative 6 squared. 36.
Yeah, I think that's right, root 40.
Which is not 6. So seems like it's not a kite, but it seems like they want it to be. Let's scroll up and see if we made a mistake, which is completely possible. 16, no. Okay. So it's not a kite. All right. So it's not a kite. So part A would be no. Oh boy, I need a pen, not the wiggle thing. Okay. No, why is it not a kite?
Because the two consecutive sides are not congruent.
You got it. Let's see. Right. Next one. The sidewalk is built that connects the arcade, tennis court, miniature golf, and restaurant. Okay. Okay, tennis court, miniature golf, and restaurant. There's a, oh, my pen kind of slipped, sorry. There's the sidewalk. What is the shape of the sidewalk? What does it look like?
A trapezoid.
How can you test to know for sure if it's a trapezoid?
By finding the slope of the line that connects the arcade and the miniature golf course, and actually tennis court, or just, I can finding the slopes of the top and bottom lines.
Yeah.
The baselines.
The words
make
kind
it
of blur together. This one and this one, right? They all kind of darkened, but the ones I tried to darken more was to make them green. So the green ones, if those are parallel, then it's going to be a trapezoid. So how do you test to see if they're parallel?
Finding the slope.
Yep. So rise 1, 2, run 1, 2, 3. So the top one is 2/3. You can do slope formula, but if it's in the graph, you might as well just count. And then rise 1, 2, run 1, 2, 3. Even though my line's all over the place, it does hit that point. They do have the same slope, so that's right. Is it an isosceles trapezoid or just a random trapezoid? How could you know that for sure?
Find the distance of the two legs.
Mm-hmm. I'll make the picture even more messy. I'll get another color. So this one you can count. It'll just be 3. But from here to here, you have to do distance formula to be sure. Let's see. 1, 2, 3, 4. 1, 2, 6. So the tennis court is 4, 6. And the golf is 7, 5. So let's see. 7 minus 4. 5 minus 6. Squared is 9. Squared. So is it isosceles or just a plain old trapezoid?
I'd say it's a plain old trapezoid.
It is. All right. Then what is the length of the mid-segment of the sidewalk in part B? So the mid-segment does what? How do you draw a mid-segment?
It would bisect the side line, will basically cut the shape in half.
Yeah. It connects the midpoints of the legs. Oh boy, it's jumping all around. It would connect the midpoint of the two legs of that shape that we drew, and now it doesn't want to cooperate. Let's see. Uh-oh. Might have to close it and come back. It's not wanting to let me draw anymore. All right, let me close it and open it again. Just 1 second. There we go. Okay, so in order to know that the length of the mid-segment, we actually have options. You could find the midpoint of each of the legs. It'll be about these spots that I'm drawing, not exactly, but you could find those coordinates and then do the distance formula. So you do midpoint and then do distance. So that's one option. Or you can use the theorem that is about midpoint, and it says that the mid-segment, I'm saying midpoint, the mid-segment is half the length of the sum of the bases. I think this thing doesn't want me to erase because now it's done it again. So if you find the length of the bases and add them together and divide by 2, that would give you the length of the mid-segment as well. Okay.
It's probably glitching because you have a lot of tabs up.
Yeah, maybe so.
You got your Ray-Bans going on. I see you.
I know. That's my anniversary present. I have to save them so I can show my husband what I want.
Yeah, I got you. She wants 3 pairs, not just 1 pair.
No, definitely not. It's going to be barely 1 pair. So if you're doing the mid-segment theorem to do it, then you need to find the length of those red/green pieces, the bases. So the top one by the tennis court up there, I'm scared to erase now because it's acting crazy when I erase. Let's see. So over by the arcade is 1, 2, 3, 4. And then by the tennis court, we already got that. So 4, 6, and 1, 4 will give you that length. 4 minus 1, 6 minus 4. Are y'all following this?
Yes.
Okay, I don't want to leave you behind. I know we've done distance formula so many times, but it's still important that you understand how you're plugging them in and solving. A squared is 9. It is 4. So the top base, the one by the tennis court, would be the square root of 13. Then the bottom, and since we're just going to plug it in our calculator in a minute to find the sum and divide by 2, just leave it that way. Don't get a decimal and round, because the quicker you round, the more off your answer will be. So the bottom, or the other base, is 1, 1, and 7, 5. So 7 minus 1, 5 minus 1, 6 squared, 36, plus 4 squared, 16. So root 52 is the bottom. With all the scribble everywhere. Are y'all still with me?
Yes, ma'am.
So this is one base. And this is another base. So to get the length of the mid-segment, which is that kind of purplish pinkish line between them, you need to add those two and divide by 2. And I would just straight punch it in the calculator like that. Go ahead and add them first, and then whatever you get, divide it by 2.
I got 115.6.
52. Let's see.
I got 10.81.
Never mind. I might have done that wrong.
Let's see.
Sorry.
Not even there yet. So I punched the wrong thing in my calculator.
Here, I'll show y'all on the camera what mine looks like.
Okay, it's like 10.8.
Let's see. 10.8. What you got?
Like this way.
Oh boy.
Yeah, it's not working. There, can y'all see that? No.
Very blurry thing.
Blurry. Yeah.
Yeah, not gonna work.
When I added the square roots, I got 10.8 something.
Yeah, I actually got
Yeah, that's right.
10.8. Yeah.
And then divide by 2, because whatever the
5.40.
yeah, that should be right. So because you do
5.41.
the sum, but then divide by 2. So this is a mess. 5.4, we'll just say, would be for part. If anybody else gets on and they're like, hey, show me number 16, just to be funny, I should just put the screen up and don't say a word. Just
That would be great. Just do
Oh
that.
wow.
Just do that. And, like, copy it. Just be like, copy this down and you'll be fine.
I wouldn't do that. That would not be nice.
You should just erase it all and then be like, you figure it out yourself.
All right. As messy as it is, did y'all follow the process?
Yes, ma'am.
Yeah. Okay.
Yes.
The process was really a bunch of old concepts because it's a lot of distance formula and slope. You
Yeah.
just got to figure out how those pieces fit together.
Mm-hmm.
Mm-hmm.
Or if somebody asks, could you do number 16? You just say no. Just no.
Other questions?
Not right now, for me.
Okay.
Thank you.
I saw for number 11 and it was kind of confusing, but I think I got it right. So
11. Uh-oh. Okay.
so I did x squared equals 9 squared plus 8 squared.
Mm-hmm.
X
And
squared.
that gave you this, right?
Yeah.
Uh-huh.
I ended up getting x equals root 145.
Okay, let's see. I think that one will break down some more. Like if you do the little tree thing.
I did that. I did that for both of these and they both would not break down.
Really?
It was really weird. Like I got 29 and 5.
29 and 5 is this one?
Mm-hmm.
That's 2. Maybe 10, maybe
They're
4.
both prime numbers.
How about that? All right. And what did you get for this side?
For 130, I kept it as root 130
Root 130.
because I did 10 and 13, which equals 130, and I got I got under 10, I got 2 and 5, and then 13 doesn't go down anymore, and there's nothing
That's
that
right.
can combine. So it was weird.
Let's see. B number 11. Boom. Look at that. Good job. You see it over here?
Wait, you can just keep this page up if you want.
No. But here is, you got it right. Root 145 and root 130. How about that? Good job.
How about that?
That's why I wasn't too stressed about the kites because they're not really, really, really difficult. It's a new thing, but they're not too tough because it's really just right triangles inside of there.
Yeah.
All right. Anything else?
I'm gonna try to do this 315, and then if I have any questions on that, I'll let you know.
All right. But if you have questions on 16, I'm not going to answer.
Okay.
All right. Let me know.
Okay. Yes, ma'am.
Hello, Mr. Sickley.
Hello there. I had a minute or two here. I'm sorry to interrupt anything.
No, you're good. Do you have questions?
No, didn't know if you guys were going over problems or breaking anything down.
We worked. I'll show you what we worked. I'll put it back. I just switched off the screen. It's a mess. We were just joking how if someone had a question about number 16, I should just not be nice and say, oh yeah, look right here. But we worked 16 in each step. That's the last one we did. Where the first part you have to see if it's a kite. So we did the distances and we did the distance like from the pool to the restaurant and the pool to the miniature golf. And they weren't the same, so it's not a kite. And then we saw that sidewalk they drew was a trapezoid because the red lines there were parallel. And it's not an isosceles trapezoid because the legs weren't congruent. And then C is most of the mess. We found the length of the mid-segment because we found the length of the two red pieces, which was the thing circled in blue there, those square roots. And then we added them and divided by 2 and got 5.4. That was the last one we worked.
Wow, that looks like a good problem.
Yeah. I was just telling them, nothing there is really new except the like add and divide by 2. It's mostly distance formula and slope. You're just using them in a different way.
Mhm.
And then earlier we talked about the kite because in class we didn't get to the kites. We're going to do that tomorrow morning before we do our pi thing. But basically that it just makes right triangles inside there so you can use Pythagorean theorem.
Gotcha.
And earlier we talked about opposite angles. One pair of opposite angles in a kite is congruent. So, we did these two about trapezoid. Isosceles trapezoid has 2 pair of congruent angles.
Okay.
That's what we did. It's a mess, but that's what we did.
Nice.
Yeah.
All right. Well, Jake and I are going to roll up our sleeves and get our hands dirty.
You got it.
All right.
Like I said, in class, we did not really talk about the kite. We kind of ran out of time. But I asked them if they would look at the information in the book about the kite. They should be able to figure out the ones that are about kite, but it won't count against them. But I do want them to try.
Sure.
So, but the trapezoid stuff we did go over for sure.
Gotcha. Okay. Thank you
All
so
right.
much.
Have fun.
All right. See ya. Thanks.
Bye.
I could not stop from laughing just now.
Why?
Oh, that's just funny. It's funny because he teaches geography, and I didn't expect him to join this video call.
He used to teach math at public school, and so he does some tutoring. So, if you don't use it, you aren't as fresh on it. So that's probably why I popped in to see exactly what we're working on right now.
That's cool. Because I think Jake takes your geometry class, right?
Yes.
Yeah.
3rd period.
So, yeah. Oh, that was pretty funny though. Because I really didn't expect him. He just like kind of popped on. I was like, why is my geography teacher on it?
Checking up on you, make sure you're doing what was right.
He's checking up on me.
Any other questions?
No, man. I'm just doing the 12 through 15 problems. And I'm basically just doing it like when we find mid segment though. I'm doing for number 12, for instance, I did 10 plus 44 equals 2x minus 1, and then solving from there.
Almost. So close.
Okay.
But you do add 10 plus 44 to get the mid segment. But what do you do to it also? You add it and
Divide it?
by 2, right?
Yeah. Well,
So-
I wasn't done. That was...
Oh, gotcha. Okay, so when you set up your equation, though, I'm not sure. Oh, come on. I'm trying to show you so I can look at the problem with you. So we're looking at the same thing. When you set up your equation, though, if you do just 10 plus 44 equals that.
It doesn't really work out because I just did it and I did not get...
Yeah. So 10 plus 44 divided by 2 will equal that.
Oh, I got you.
When you have all the numbers, you can divide by 2 at the end. Because like in that big problem down there, 16, we got the 2 bases by working all that stuff. And then we divided by 2. So you've got these 2 bases. So you know the length of the mid-segment is how much? Like without the x thing. Just 10 plus 44 divided by 2 is how much?
22.
No? 10 plus 44 divided by 2.
1 sec.
Basically, how much is all this side of the equation?
It is 27.
27. So we know that this is 27 long. Does that make sense?
Yes, ma'am.
If it just said how long is MN, you'd say 27. But since they want you to solve for X, you need to say, okay, I know that it's 27. And 27 is the same thing as 2x minus 1.
I got it right.
That makes sense?
Yes, ma'am.
Okay. So that if you write your equation that top way, this up here, that takes care of everything. And then you could just solve the left side first since it's all numbers.
Okay.
You can get rid of that how crazy it looks by just doing your adding and dividing on the left.
Yeah. So I will ask you for number 13. Do I do 43 plus 4x divided by 2 or divided by something else?
Okay, my problem's all wacky. What is the left side? What is that number?
Far left is 43, then mn is 32, and then the right one is 4x.
Okay, now tell me what you said and I'll tell you if it's right. I couldn't tell what my numbers were.
So am I doing 43 plus 4x divided by 2?
Equals 32. Yep.
Divided by 2 equals 32.
And so this one, your variables over there with the 2, 43 plus 4x divided by 2. So the top and the bottom divided by 2 equals 32. So this one, you can't just get rid of that fraction by adding and dividing, but you can get rid of the fraction we talked about yesterday. How do you clear a fraction?
Well, if you divide by 2, I got 21.5 plus 2x equals 32.
Let me think. Yeah, that should work. That's fine.
Okay. And then subtract 21.5.
Oh boy. I was trying to erase and I made my pen too big. Sorry.
I got 10.5 equals 2x divided by 2. That was 5.25.
10.25. Sorry, I'm following.
You're good.
32, subtract, divide by 2. And you got what?
I got 5.25 for my answer.
Boom. Good job.
Awesome. Thank you.
I was going to show you if it's a weird decimal at some point, there's another way you can get rid of that too. Because you went from this to this. There's another way. You don't have to do it. I'm just going to show you so you're aware of it. I'll do it in blue so it stands out. Okay, so if you have a denominator like this 2 and you want to get rid of it, you can multiply both sides of your equation by that denominator.
Okay.
So on the left, it'll go away. And on the right, you would have 64. So then your
So you're saying multiply everything, like kind of like a, you know what I'm saying? Like the other way we.
Yeah, you don't have to do that. What you did is okay as long as you remember, and you did it right. You divided each of these pieces by 2. Sometimes people are like, oh, it's just 43 plus 2x because they see the even number and remember.
I kind of thought that at first, but like, no.
Yeah, so either how you changed it in the red is fine, or you can change it like the blue, multiply both sides by 2 to get rid of that denominator.
Yes, ma'am. Yeah, I think I'm gonna just kind of do it the way I did the way you wrote it down in red, because that's just usually way how I've done these problems, and so I kind of don't get confused if I don't do it that way.
Yeah, the fractions throw people off sometimes, so the blue is called clearing the fraction.
Okay, thank you.
All right, couple more minutes. Anything else? Bryson, you still doing okay?
Yes, ma'am. Thank you. I don't have any more questions.
You're good? All right.
Thank you.
You're welcome.
Thank you, Miss Glenn. I think I'm going to get off too.
Okay, y'all have a good day. If you think of something, you can email.
Okay, thank you.
Okay, thank you.
You're welcome.
Have a good day.
Thanks, you too.